So on the last page, again, it summarizes the three theorems. You have the IVT, MVT, and EVT. So just as a reminder, IVT has to be continuous on the closed interval. Okay, that is the condition. It has to be continuous on the closed interval. Okay, you kind of, anytime they ask if something equals a number, if f of c equals 5, that's your clue that it's an IVT type question.
Is f prime of c like equals 5, would that be the MVT?
That would be the MVT, yes, as soon as they start talking about slope. So again, all this is saying is if at one point a value I'm here and another one up here, at some time I must hit in between there as long as this function is continuous. And again, you kind of just, we'll practice writing these out in a second. We'll just kind of go through the three theorems. MVT, okay, so now M stands for slope. Back in middle school we said M is your slope. So this has to be continuous on the closed and differentiable on the open. Okay, so your sentence is going to have to start with those two conditions. And if they're not met, then the MVT doesn't apply. Continuous on the closed, differentiable on the open. Now I want you to box this in. This is the theorem you have to know. F of B minus F of A over B minus A equals F prime of C. This side represents the average rate of change. This side represents the instantaneous rate of change. Rate of change. A lot of times we'll just use that phrase instead of saying MVT. They'll say, when does the average rate of change equal the instantaneous rate of change? Okay, and again, you'll kind of write out your formula or your vocabulary after that. The EVT, okay, the only condition is that you have to be continuous. And all the EVT says is that if you're continuous, you are guaranteed to have a max and a min. If you're continuous, you're guaranteed to have a max and a min. Now, the way they write max and min is really important. You'll see this notation in here. F of c is greater than or equal to f of x, represents our absolute max, and f of c is less than or equal to f of x, represents our absolute min. Okay, and it just says every continuous function has an absolute max and an absolute min. But those are the three theorems that we've got to keep straight. So again, this is going to pull up some multiple choice type questions. I'm just going to kind of skip around to ones that I think are important. Let's going to start with 11. This is a common question. All right, the function f is continuous. Okay, so right away they're telling me it's continuous, so IVT and EVT are applied. And is differentiable. So now I can also use MVT as I'm looking for these things. And I'm given 2 points. So take a minute and plot your 2 points. Make a quick sketch. And plot your 2 points. Okay, and all we're basically saying is we know we're going to get from this point to this point without picking up our pencil. It's continuous. The most simple thing it could be is a line, which is usually not it, but it could be a simple line. It could be something crazy like this, right? We don't actually know what it looks like. We just know it goes through those 2 points and you draw it without picking up your pen. Okay, which of the following could be false? So we're looking for something that's not true. F of c equals 0. What theorem are they describing when they just say you're going to hit 0? IVT. So let's make a note. That is the IVT. Am I guaranteed to hit 0 the way I have my 2 points? 100%. This is definitely true. And again, we're looking for a false statement. Is there another choice that represents IVT? C. Good. Let's put IVT there as well. Based off my 2 points, am I guaranteed to hit 3? Absolutely, right? I'm above it and below it. So that is also true. Okay. All right, let's look for an EVT. EVT says I'm guaranteed to have a max and a min, and I know that's true because I'm continuous. Which choice looks like an EVT? the last one E, right? This is saying right here is that notation for a max. So let's put EVT. And again, that's true because my function is continuous. Okay, now the other two choices are about slopes. So these are both about MVT because they're both asking about the slope. So all I really can do at this point is say I have 2 points. I should probably find this slope. So take a minute and find the slope between those 2 points. Let's see, I've got 9/3 or 3. So I would say the slope has to equal 3 because I had those 2 points and it came out to be 3. Therefore, this one could be false. It could be true, but it could be false. I did not magically come up with a number to get me a slope of 0. Again, if it was just a straight line, it definitely wouldn't have a slope of 0. Okay, so we're just recognizing when we see this in a multiple choice, IVT versus MVT versus EVT. Go ahead and try 12. That's a super easy common question. And think about what theorem they're hinting at. Dan, what theorem are you thinking? IVT, excellent. I just want to know if I hit 2, and they're telling me it's continuous. I can't use MVT right away because I don't know if it's differentiable. I only know it's continuous. So how many times do we think it hits 2? Sully, how many times does it hit 2? 3. Between what 2 numbers?
Between 0 and 2, 2 and 5, and 9 and 11.
Perfect. Yep, definitely 3 times. So again, just another way to see that IVT type question. Let me keep looking here. Let's try number 8. A little uglier. The function f is defined by this function, the application of the mean value theorem. So now they're telling you to use the mean value theorem. So let's start with the theorem. F of b minus f of a over b minus a equals f prime of c. Average rate of change equals instantaneous rate of change. Guarantees the value of c between 0 and 2 such that f prime of c equals what? Now, they're actually just saying, what is f prime of c equal to? So all we have to do is evaluate this side and we'll have what f prime of c equals. And they want us to use the numbers 0 and 2. So all we need to find is f of 2 minus f of 0 all over 2 minus 0, and we will get f prime of c. We just got to crank out some numbers here. Let's see, I'm going to do f of 0 quick. That's just a 1. I need f of 2. 2 squared is 4. 4 times 4 is 16. Minus 10 plus 1. Are we getting 7 for that? F of 2? 7 minus 1 is 6. 6 divided by 2 is 3. I think I get 3 equals f prime of c. So I didn't actually find the value of x that satisfies it. That wasn't the question. That was just kind of halfway through the question. I think we get a nice c equals 3. I'm going to keep looking for some uglier ones. Let's try number 3. We'll try some of the short answer as well. Let f be a function with the first derivative given. It is known that f of 1 equals 7, f of 5 equals 11. Find the value of x, and I got to solve the whole thing that satisfies the mean value theorem. So again, I'm starting with that formula. F of b minus f of a over b minus a equals f prime of c. And they clearly want us to use 1 and 5. So f of 5 minus f of 1 all over 5 minus 1 equals, now I need f prime. Do I have to do anything or did they give it to me? They literally gave it to you. You're just plugging in f prime at this point. Usually you would take the derivative, but they were nice enough to just give it to you. And they were actually really nice to give you all these values. F of 5 is just 11 minus f of 1 all over 5 minus 1. What does that get me? 7 to 11 is 1. Does 1/4 sound good there? Am I losing my mind? 4/4. 7 to 11 is 4. 4/4 is 1. How about 1? 1 equals 2x squared minus 5 over x squared. Again, I would probably just cross multiply to solve that. So x squared equals 2x squared minus 5. Put my x squareds together. I'm going to bring over this negative 2x squared. So I'm going to get negative x squared equals negative 5. They're not perfect squares, so they weren't going to factor. I'm going to divide out my negative. I'm going to get x squared equals 5. Now be real careful. When you take a square root, how many answers do you actually get? 2. You get plus and minus root 5. Now, they like to be sneaky on these questions. This one's not super sneaky, but they do like to do this. Your answer has to fall in between the interval 1 to 5. It can't be an endpoint. It has to fall in between there. So even though it's not a choice, if it was a choice, we'd have to make a smart guess, a smart decision here. I can only take the positive square root of 5. That's the only number that falls in between 1 and 5. Okay, it's got to fall in between. All right, let's try some short answer type questions. Number 13. So these are from all old free response questions. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup is given by this differentiable function c, which is measured in minutes, or t is measured in minutes. Selected values of c of t measured in ounces are given in the table above. So this was like a part C to a question. Is there a time between 2 and 4 at which c prime of t has to equal 2? So what theorem are they hinting at based off what's given and what they want? MVT. Right off the bat, we got to catch this is an MVT. How do we know? Well, we're taking the what of c? The derivative, the slope. The second I'm taking the slope, I'm thinking MVT. So I want to look for the keywords first. In order to use MVT, the conditions have to be met. I have to be continuous and differentiable. I'm going to highlight this word differentiable. Okay, differentiable implies continuous. So I know I can use the MVT because they are both differentiable and continuous. They're specifically telling me to look from 2 to 4, so I'm going to start with those numbers. So I'm going to say c of 4 minus c of 2 all over 4 minus 2. I'm doing the slope because we said it's the MVT. C of 4 is 12.8 minus 8.8 all over 2. That gets me 4 over 2, which is 2. Okay, so now the write-up is the key part. So we have to first address the two conditions. So is there a time? I'm going to answer yes. Since c of t is continuous on the closed interval 0 to 6 and differentiable on the open interval 0 to 6. Okay, so really you got to state your conditions, and then you kind of just repeat the question with the theorem. I'm going to say the MVT guarantees whatever I wanted, c prime of t equals 2, since, and then you kind of just put, your mathematicians just put their math in their work. You can just stick that right in there. Since c of 4 minus c of 2 over 4 minus 2 equals 2. Okay, so again, the conditions have to be met. You have to talk about the question and the theorem and stick your work right in there. All right, let's try 14. Train A runs back and forth on an east-west section of the railroad track. Train A's velocity is measured in meters per minute, is given by a differentiable, there's a keyword, function. Selected values for v sub a of t are given in the table. Do the data in the table support the conclusion that train's A velocity is negative 100 meters per minute at some point between 5 and 8? What theorem are they describing? IVT. So let's just make a note. This is IVT. I'm just literally looking at the table to see if this velocity is going to hit negative 100. So does the data claim this conclusion? Yes or no, would we say? Yes, definitely does. Okay, and again, I'm going to pull up my justification. So since they told us V of t is differentiable, then it's also continuous on the closed interval 0 to 12. Okay, they told us it's differentiable, which implies continuity. Then I'm just going to repeat the question. V sub A of t equals negative 100 by the intermediate value theorem. And then we got to show where it's happening. So where do I hit negative 100? Between what numbers? 5 and 8. So V sub A of 5 is greater than negative 100, which is greater than V sub A of 8. Okay. And if it happened in more than one place, you would just list out all those intervals. All right, but that's just the main, difference between the two. We need to state continuous and differentiable versus this one they told us differentiable, so we are applying continuous there. Let's see if anybody else sticks out here. Go ahead and try 15. Continuous function is defined on the closed interval. The graph consists of a line segment, digit the x-axis. It is twice differentiable. Is there a value a for which the mean value theorem guarantees to have f prime of c equal to 1/3? So start with your mean value theorem. Okay. Yeah, I think that looks good. Thank you. You too. I hope it's fairly obvious. Once you write out the mean value theorem, obviously you're going from 6 to A. If you want the bottom to equal 3, what does A have to be? A has to be 3, right? 6 minus 3 is the only thing that's going to get me 3. So let's let A equal 3 and see if this works out. So if I have f of 6 minus f of 3 all over 6 minus 3, I know f of 6 is 1. F of 3 is 0, all over 3. I definitely get the 1/3. So again, to justify your answer, you're just going to have to write up the correct reasoning. So I'm going to say yes. What is our function? F is twice differentiable, which means it's continuous and differentiable. So F is continuous on the closed interval and differentiable on the open interval. Then the MVT guarantees whatever I wanted it to, f prime of c will equal 1/3 when a equals 3 in this case. And I think I've got all my work there to back it up. So again, if I'm equaling a slope, I'm thinking MVT. If I'm equaling a function, a number itself, I'm thinking IVT. I'm trying to see if there's another extreme. The extreme value is usually just a multiple choice question. Just trying to see if one pops out here. Let's look at 7 real quick. It's a nice easy one. which of the following theorems may be applied to the graph below? Okay, so looking at the graph, you just want to run through the conditions. Is the function continuous looking at it? Yes. So who gets applied if it's continuous? I can use IVT and EVT. Is the function differentiable? No. Why? Sharp point. Okay, so MVT is out. So I have to look something about just IVT and EVT. And again, that EVT is just saying I'm guaranteed to have an absolute min and max. And as long as it's continuous, it's true. So I think choice 1 is out, leaves us with choice D. Okay. So again, I just picked this packet. It was already printed just to go through. You can do what you want with it. This is not homework, just to be clear. This is not homework. Just trying to go over some extra mean value IVT, EVT. The homework tonight is the review packet you picked up that goes with the video. If you're stuck, my answers will be posted by 4th period. But get a head start on that. Like I said, it's going to run through every topic that the AP covers in 8 sessions. Okay. Make sure you